Hello, everyone, and thank you for joining us, and welcome to the Qt Virtual Tech Conference 2020 webinar titled SSL/TLS in Qt, Introduction to wolfSSL. Our speaker today is Chris Conlon. He's the engineering manager at wolfSSL. Before I turn the mic over to him, a few housekeeping items to cover. Today's webinars will be available on demand after the live session, so you can return to the live event page to watch at a later time. We'd love to hear from you during the session. If you want to put your questions in the Q&A, down below you'll see the Q&A, and at the conclusion of the presentation, Chris will answer the questions. Anything we don't get to answer, we'll certainly follow up with you. So without further ado, I will turn it over to Chris.
Thank you. And hello, everyone. Thanks for attending our session today. Like was mentioned, this is titled SSL and TLS in Qt. So today we're going to start out with an introduction to wolfSSL as a company and product. Take a look at what's existing in Qt for SSL and TLS support. Go over some advantages to why you might want to use wolfSSL over an existing TLS implementation, and then how you can build Qt together with wolfSSL. Like Michael mentioned, my name is Chris Conlon. I'm an engineering manager with wolfSSL. I'm based out of Bozeman, Montana, and I've been with wolfSSL for about 10 years now. So we're excited to work on this integration and see what how people want to use it going forward. So first of all, let's take a look at wolfSSL as a company and product. So wolfSSL really began in 2004. MySQL, the database company, needed a clean room SSL implementation. At the time, OpenSSL existed, but there were some questions about the consistency of license throughout the code base. And so we took it upon ourselves to solve that problem. We wrote an SSL library from scratch in 2004 called YASL, which stood for Yet Another SSL. That was written in C++. And was still distributed in every installation of MySQL. So between 2004 and 2006, the market, especially the embedded market, really demanded a SSL library written in C. We sat down and rewrote it again, this time in C, and called that CYASL, Yet Another SSL written in C. It turns out the naming CYASL was a little hard to pronounce. No one really knew what it stood for, so in 2014 we renamed it to wolfSSL. So the same product, just a more consistent name across our products, easier to understand and easier to say. So we've been growing as a company ever since I started in 2010. We were 3 people then, now we're up over 30 now in 2020. We have over 1,000 commercial customers that use us in products, 17 partners that resell our products, and we estimate that we secure about 2 billion endpoints at any one time on the internet. This slide shows our current product lineup. So that first row in green boxes, those are our primary products. Our main product is wolfSSL, an SSL and TLS library. Underneath that sits wolfcrypt. This is our cryptography library. We have a couple certified and validated versions of that for FIPS and DO178. We also have a version of that that can be used on the server side with accelerator cards for TLS, like Cavium Nitrox or Intel Quick Assist, for example. We have an MQTT client library, an SSH client and server implementation, a TPM 2.0 library, and our newest product this last year is a secure bootloader called wolfboot. Now, all those primary products are written in C. We do have users who'd like to use us from other languages. So the second row is a set of language wrappers. We have a set of Java wrappers that include a JSSE and JCE provider. We have a tight JNI wrapper around wolfSSL. We have a C# wrapper, a Python wrapper, and also a JavaScript wrapper. And then the third row on this slide is a set of applications. So we have an SSL termination proxy, a simple certificate enrollment protocol implementation, a secure update solution, a command line utility. The author of curl now works for wolfSSL, so we provide commercial support for curl. And we've also produced a version of curl called tiny curl, which is a pared down version of curl meant to fit better on resource constrained devices. So wolfSSL and wolfcrypt are what we'll be talking about today. We've integrated this into Qt to provide an alternate SSL and TLS solution. So wolfSSL itself is a TLS library. It's written in C. It's built from the ground up to be portable and lightweight. It supports up to the most current protocol standards of TLS 1.3 and DTLS 1.2. Typical footprint size on an embedded target is usually around 100 kilobytes. The smallest build we've done to date is 20 kilobytes. Runtime memory usage is 1 to 36 kilobytes per session. And the footprint size of wolfSSL is typically about 20 times smaller than OpenSSL on a desktop or enterprise type system. We've ported wolfSSL to about every operating system that we've encountered today, and you can see those at the bottom of this slide. That includes your standard Linux, Windows, Mac, as well as a variety of different RTOS platforms. wolfSSL itself is dual licensed under GPL v2 and a commercial license. This means you can download our open source code direct from our website, or if you'd prefer to track our development release and master branch, you can find us on GitHub. We do offer professional support that comes right from our wolfSSL engineers, the same engineers developing the product. And we do have consulting services for integration of new features or porting. So let's take a look at what's existing in Qt today for SSL and TLS. And this may be a review for some of you that are already familiar with the SSL support in Qt. So there's a set of secure socket layer classes in Qt. You can see here a screenshot from the Qt documentation. And you can also note that Qt is using OpenSSL as a backend for SSL and TLS support by default. Qt greater than 5.6 supports OpenSSL 1.0.0 or later. One example of one of these classes is the QSSL socket class. So this is a class that provides SSL encrypted socket for either client or server communication. This also is using OpenSSL underneath by default. And then if we look, how do you compile Qt today with OpenSSL support? So when you're building Qt from source, the configuration system will automatically try to use the version of OpenSSL you have installed in your system. That might be something you've gotten from something like apt-get on Debian or Ubuntu, for example. So the configure script automatically will check for the OpenSSL/OpenSSL-v.h header file, and it will load the OpenSSL libraries dynamically at runtime by default. You can link against those libraries at compile time using the -OpenSSL-linked option. And when you're building Qt from source, it tries to automatically link against those OpenSSL libraries, and their names are libcrypto and libSSL. OpenSSL has two libraries for their SSL TLS crypto support, whereas wolfSSL will only just have one library called libwolfSSL. The location of the OpenSSL libraries is configurable using the OpenSSL_libs environment variable. You can see here on the middle of this slide an example of setting that and setting the linker path, as well as linking against the SSL and crypto libraries. It's also running configure with the -OpenSSL-linked option. You can disable SSL and TLS support in Qt by using the -no-OpenSSL build option. So, you know, a lot of you are probably wondering why did we want to integrate wolfSSL into Qt, and what advantages might you see from that as an end user? And so we'll be going through this list in the next couple slides, but there's a variety of reasons someone might be interested in a different TLS implementation, and it may depend on your use case or your type of application. The first advantage is protocol support. So since wolfSSL was founded, we've been one of the first to implement new versions of the TLS protocol. We were one of the first to implement TLS 1.3, which is the current TLS version. We have client and server-side support for that. And we also have DTLS 1.3 on our roadmap. Right now, the RFC and the spec is still working on reaching the point of finalization, but as soon as that happens, we'll begin implementing that as well. The SSL protocol itself has been around since 1995. It was invented by Netscape, with SSL 2.0 being the first version being released. SSL itself went through 2 revisions, 2.0 and 3.0. In '99, the protocol changed enough that the name changed to TLS, or Transport Layer Security. TLS has gone through 4 revisions itself, 1.0, 1.1, 1.2, and 1.3. And then paralleling TLS development has been DTLS. This stands for Datagram TLS. This is essentially a version of TLS designed to be run over unreliable protocols such as UDP. You might find this commonly used in a VoIP type application. And then all this code is also actively maintained by the original authors. That makes it quicker for us to fix bugs, easier for us to add new features and such. Another advantage to wolfSSL is footprint size. So wolfSSL can be up to 20 times smaller than OpenSSL. When I was putting together this slide deck, I did a quick footprint size benchmark on Ubuntu 18.04.4 on an x86-64 platform. You can see those numbers here in the middle of this slide. wolfSSL 4.4.0 compiled just using the default configure was 463 kilobytes. OpenSSL from apt-get libSSL was 580 kilobytes, and libcrypto was 2.9 megabytes. So you can see there's a significant difference in footprint size between those two. And that was just on a regular desktop system. On an embedded system with an optimized compiler, the wolfSSL size will be much smaller than that. And so reduction in footprint size will help Qt fit on more resource-constrained devices. The next advantage to wolfSSL is the amount of testing that we do on our library. So as a security product, we know that testing is one of the most important things that we can focus on. And as such, it's a high priority in our development cycle and process. We have a goal of being the best tested TLS library available to users today. And we put a lot of work into adding different types of testing and integrating those all into a continuous integration cycle. So we know they're happening on a regular basis. And so we use Jenkins on the back end to test on each pull request that we open on wolfSSL, as well as doing more lengthy nightly test cycles. So we do everything from API unit testing to Cipher Suite testing. We do benchmark testing, so we make sure we don't slow the library performance down. We do static analysis with tools like Coverity, ScanBuild, and Facebook Infer. We do memory testing with Valgrind and Clang's fsanitize address. Interop testing against other TLS implementations. Real-world builds, where we're actually building customer configurations on a nightly basis. So we make sure we're not breaking our customers' builds. Testing against several different compilers, doing peer review, third-party testing, and also some fuzz testing. We have several different internal fuzzers we've developed, and also make use of AFL, TLS fuzzer, libfuzzer, and OSS fuzz. Another advantage to wolfSSL, and this is maybe dependent on what industry and application type you're working on, is certifications and validations. So underneath wolfSSL, we use wolfcrypt, which is our cryptography library for all crypto operations. And we have a couple different versions of wolfcrypt that are validated or certified. So we have a FIPS 140-2 certification. This is oftentimes required in Department of Defense and government type projects. Oftentimes it's more of a checkbox item. We have 2 certificates for FIPS 140-2, 2425 and 3389. And FIPS uses what's called an operating environment, or OE. And an OE is a combination of an operating system, the version of that operating system, and the processor or chipset that WolfCrypt and wolfSSL will be running on. So we can easily add new OEs to those existing certificates. The second certification we have is DO-178. This is a safety certification typically required in avionics systems. And then we have a version of WolfCrypt that we've conformed to MISRA-C coding standards. And so that's oftentimes required in safety applications like automotive. And so any of these certified versions of WolfCrypt can easily and seamlessly be plugged underneath wolfSSL. The next advantage to wolfSSL is portability. We've written wolfSSL from the ground up with portability in mind, and we've tried to abstract out all of the platform-dependent code and areas of the wolfSSL and WolfCrypt code base. So, there's some examples I listed here on this slide. Time, when we use that for session cache expiration or certificate validation. We've abstracted getting the seconds since the unit epoch out to X time, which is a macro that's mapped to time, the time function by default, but also mapped down to any other specific time function on the ports that we've done. Likewise, for memory management, we abstracted malloc free and realloc to xmalloc x free and x realloc. So that lets users override those memory functions if they want to do their own memory management. Another kind of cool thing you can do with wolfSSL is taking advantage of hardware cryptography. So we've added hardware crypto support for a lot of different modules. And so by default, wolfSSL will use our software cryptography. But if a hardware crypto implementation is available on your platform, we can offload and use the hardware crypto instead of our software crypto. And the benefits here is that you get a reduction in code size, you get an increase in performance, and if you're using something that can store keys and certificates securely, like a secure element or a TPM module, that can also provide you increased security. Now, we typically see somewhere about 5 to 10 times performance increase when using hardware crypto over software crypto. I put just some examples of benchmarks we've done here on the bottom of this slide. The one on the left is a comparison of ARMv8 accelerations to software crypto. The one in the middle is showing you performance on an STM32L4, an ST-Safe, and then a microchip ATEC 508A module. And then the one on the right is an NXP Kinetis K60 tower platform. Commercial support is also available for wolfSSL. This can be an advantage in that your questions can get answered quickly. Your issues will get resolved quickly as well. We have some guaranteed response times, which can be helpful for projects that have deadlines and timelines. And then we also have consulting services available. So we regularly port to new platforms, new operating systems. We add new features to wolfSSL and WolfCrypt. For example, you might want a new TLS extension or an unsupported algorithm added to the library. Another common type of project for us is porting wolfSSL into open source projects. So we've done that with things like Qt, things like Apache, Nginx, Lydie, OpenSSH, OpenVPN. And so those are things that we can fairly easily do as well. And then if you need training or want to learn more about SSL and TLS protocol, about wolfSSL products, MQTT, TPM, SSH, any of that kind of stuff, that's available as well. So now that we've talked a little bit about why you might want to use wolfSSL with Qt, this section will go into a few details about how you can compile the two together. So first of all, one thing to note is that this support is still in its early phases, and it hasn't yet been merged upstream into Qt master. And so until that happens, just go ahead and email either fax@wolfSSL or support@wolfSSL.com and request access to our Qt patch file and documentation. That'll let you try it out and in more of its early stage if you want to try it before it gets merged upstream. So once you have the patch file, go ahead and download wolfSSL. You'll want to get version 4.4.0 or later, and you can get that either from our website or directly from GitHub. Now that you have wolfSSL, we'll want to configure it with Qt support. So wolfSSL uses the autoconf system by default on Unix Linux type systems for configuration. And so we've added a configure option called enable-qt, which will enable Qt support. You can see here we're doing that. We're running make to compile the library, running make check to run our built-in unit tests, and then installing the library with make install. And then by default, wolfSSL will install itself into the user local directory. You can override this if you want to install it into a custom directory using the -- prefix option. Now that we have wolfSSL compiled and installed, we'll want to compile Qt. So first of all, follow the building Qt 5 guide in order to set up your Qt dependencies and initialize your Qt repository. Once you have that done, change directories into the Qt 5 directory and check out a branch, either 5.12 or 5.13. Those are just the branches that we've worked with so far. And once you've done that, you're ready to apply the Qt patch file that wolfSSL has available. You can do that using the command here on the bottom of this slide. Now, we already covered how you would link against OpenSSL. We've tried to mimic that same type of linking process using wolfSSL. So we've introduced a wolfSSL libs variable. This lets you set the library path and link against the wolfSSL library. And then we've also added, just like there's a -OpenSSL linked option, now there's a -wolfSSL linked option. And so you can see that here on the middle of this slide. We're also specifying the include path to the wolfSSL header directory. If you need to reconfigure Qt, you can do that using the git submodule commands here. And then once you've configured Qt successfully, you can build using the make command. So to test the build, you'll just run make test. That'll run the Qt tests, or you can individually run SSL related tests from the command line. Some of the examples of those tests are here on this slide for reference. So, and that's about it. That's, it's a pretty easy process. All going well, linking and compiling Qt against wolfSSL. We're looking forward to seeing where the community takes this and what other features we can expand upon from here. Do keep in mind this is a kind of a work in progress at the moment, and we would be interested in hearing any feedback you have if you end up trying out our Qt and wolfSSL integration. You can email our support team at support@wolfSSL.com and report any feedback or comments that you might have in that process. So with that, yeah, thanks again for listening to this short presentation today. Hopefully it was informative and it gives you another option for SSL and TLS support. With that, I'll open it up to any questions that people may have.
Thank you, Chris. You have one question so far.
Sure.
You click on the Q&A. Another one just came in.
Okay, so we have one question. Do you plan on getting validated, certified for the medical industry? We are being used in several medical applications right now. We've seen several of those using FIPS validation to meet some of their requirements. But if there's a separate validation that is required, we're happy to look into that. The next question is, when will Qt 5.14 and 5.15 be available? Will wolfSSL not work just linking a different library in stock Qt 5.15's Qt creator? That's a good question. I'm not sure on the timeline to Qt 5.14 and 5.15. If we, I recommend maybe reach out to either one of the Qt support channels or the support at wolfSSL.com, and we can definitely get that answered for you.
Yeah, we can get you the answer there. They're coming soon. I don't know about the wolfSSL, but we can find out. We can get you an answer.
And then next question, is there support for mscripton for use with WebAssembly? So we did look at mscripton with wolfSSL about a year or two ago. So we have some initial support, or at least some things we could share with you there. I'd recommend you just email us at support@wolfSSL, and we'll send you what we have existing.
Are there any other questions? Okay, well, if there aren't any other questions, again, thanks for everybody's participation. Chris, thanks for the excellent session. You can provide feedback on the session by completing the survey, and then you can also join the next live session via the events page. So again, thanks everybody, and have a good rest. Let's see if there's anything else here. Oh, there's another one. How easy would it be? Did you see that one, Chris?
Let me see. How easy would it be to use wolfcrypt to do simple encrypt, decrypt stuff in a Qt app? So wolfcrypt itself is simply a C API. So if your app can call wolfcrypt API directly, that would be pretty simple. If there's additional Qt crypto type wrapper APIs that we would need to integrate into, that would be a little extra work. But wolfcrypt does expose essentially all the crypto modules in a modular manner for you to use individually.
Okay, again, thanks everybody, and have a good rest of the conference. Thanks, Chris.
Yep, thanks everyone.